Welcome to our channel Euclid Mathematics. We have started lecture series on CSIR NET SET Gate and other competitive exam. From few days I'm explaining your previous year question from the all subject which is necessary for NET SET and Gate exam. If you wanted to see these videos and lecture, you may check it into my playlist. Now here in my today's video I'm going to explain to you all one of the question from CSIR NET. Question it is from 4.75 marks, that means paper third question, meaning that we have one or more than option true. Okay, so let's get started our today's question. I'm going to explain to you all first of all question, then we'll go for detailed understanding of our solution. Here in our solution we have given, let T be a n by n matrix with a property T raised to n is a 0. T n by n matrix with a property T raised to n 0, and then we have to find out which one of the option is a true here. So first option is that T has a n distinct eigenvalue. T has one eigenvalue with a multiplicity n. Third, 0 is an eigenvalue of a T. Fourth, T is similar to diagonal matrix. Okay, so we have T n by n matrix, and we have to prove one of the option is which one of the option is a true. Okay, so now let's get start our solution. I will explain to you all detail and each and every option. Okay, so here we have given T is a n by n matrix. That means we have T is a n by n matrix, n rows and n column. That means square matrix is given, and T raised to n is a 0. T raised to n which is a 0. And try to remember previous concept. If we have a raised to n, like a raised to n is a 0, then we say that a is a nilpotent. Okay, a is a nilpotent. When we have a raised to n is a 0, then we say that a is a nilpotent matrix. Okay, so similarly apply this condition over here, that is a T raised to n 0. That means here T is a nilpotent. Here what we have, T is a nilpotent here. If the matrix T is a nilpotent, so what the properties of a nilpotent matrix? It says that all the diagonal elements are 0, then we say that it is a nilpotent matrix. Strictly upper triangular matrix, strictly lower triangular matrix, 0 matrix, these are the nilpotent matrix. Okay, now here let's consider one counter example to eliminate option first. So first option says that T has n distinct eigenvalue. So let me consider the matrix where all eigenvalues are similar. Okay, let's consider all 0 matrix, 3 by 3 0 matrix. Okay, if we trying to multiply t square, t cube, t raised to n, we get the t raised to n which is a 0. That means T is a nilpotent matrix. Okay, so as we can see here, it seems like that lambda is a 0 0 0, which is the only eigenvalue, our matrix T possesses here. Okay, so then how can we say T has a distinct eigenvalue? It's never possible. Because of that, only the eigenvalue which exists here for T, only 0. Okay, nothing is a distinct eigenvalue over here. So option first discarded here. Okay, now let's move for the option number second, B. T has one eigenvalue of a multiplicity n. Now you may take same example. T has a one eigenvalue. Okay, you can see here it is only the one eigenvalue here which is having multiplicity n. Okay, so these are the only properties for a nilpotent matrix. Okay, if you don't know the properties, you may have to take some counter example that can make your option true or wrong. Okay, so our option B, it says that T has one eigenvalue with a multiplicity n. So here we can see that multiplicity n means multiplicity 3. Okay, multiplicity 3, it is the only eigenvalue for a 0, it is a multiplicity 3 for T. Okay, so our option number B, it says that T has only one eigenvalue with a multiplicity n. Okay, now let's move for the third one. 0 is an eigenvalue of a T. Yeah, surely it happen because it is a nilpotent matrix. That means the diagonal element has to be a 0. If a diagonal element non-zero, then we cannot get nth power of our T, which is a 0. Okay, so it is not possible. So T raised to n 0 means only the eigenvalue which are 0. Okay, so that means the determinant is also 0, and determinant is 0. That means multiplication of eigenvalue is a determinant. That means one of the eigenvalue need to be a 0, then only the multiplication of eigenvalue which is coming 0 and which is equal to determinant. Okay, so 0 is an eigenvalue of a t, which is also true. Okay, so one of the eigenvalue I found here, one of the eigenvalue I got 0. And now option number D, T is similar to a diagonal matrix. Okay, so we have to apply here the concept from diagonalization chapter from linear algebra. And when we say that matrix is a diagonal, that means we have to show here T is a diagonal matrix. Okay, so in order to show T is a diagonal, so what we have to prove here for diagonal matrix? Diagonal matrix means diagonal matrix. What is meant by diagonal matrix here? The matrix which is having algebraic multiplicity and geometric multiplicity both are same, then we say that our matrix is a diagonal matrix. So algebraic multiplicity means, what is meant by algebraic multiplicity? The algebraic multiplicity means the repetition of eigenvalue or the number of eigenvalue which occur from our matrix. Okay, so lambda 1, lambda 2, lambda 3 and so on, these are the n eigenvalues. So we say that n is algebraic multiplicity. Okay, and now what about for geometric multiplicity? Geometric multiplicity we write as a dimension which is equal to, geometric multiplicity can be written as dimension, n is a dimension of our matrix, n minus rank of given matrix minus lambda times identity matrix. Okay, so this is the geometric multiplicity. Algebraic multiplicity and geometric multiplicity need to be equal. So you may check these two conditions here in our matrix T, or you may select any other counter too, and whether if it is equal or not. So if it is equal, then you have to go for another condition for diagonalization. Okay, it is not only the condition over here, there is one more condition for diagonalization. It says that all eigenvalues, okay, all the eigenvalues from our matrix, okay, the all eigenvalues from our matrix need to be a distinct. Okay, we do not want them same. If the all eigenvalues like lambda 1, lambda 2, lambda 3 and lambda n, so on, okay, up to the n lambda, so all we need a distinct eigenvalue. So this one is a distinct mean all eigenvalue need to be a different. So here we can see that we can eliminate that option only using our second part. Okay, so you may go for AMGM checking, algebraic multiplicity and geometric multiplicity, but it is quite time taking. So directly check the option of part second for diagonal matrix, diagonalizable matrix. If it hold, then come here. If it not hold, then eliminate option, discard it. Okay, so if it hold, then you have to check algebraic multiplicity, geometric multiplicity. But here in our matrix, we consider this a matrix here, nilpotent matrix, which is having all eigenvalues are equal to 0. So all are 0. So we cannot write 0 not equal to 0. Okay, so this is not possible. So all eigenvalues are 0 over here. So if all eigenvalues are 0, then we say that our matrix T, which is not a diagonalizable matrix. Okay, the condition for diagonalization, it is broken here. So we cannot apply or cannot say our matrix is similar to diagonal matrix. Okay, so option number D, which is a wrong here. So from our option A, B, C, D, the option number A and the option number D both are eliminated, and the correct option here, option B and option C. Okay, now let's check out the complete solution for our example. Here we have the complete solution. You may refer it into the your understanding. Okay, so here it is a complete solution. Might be my solution is a different than my explanation. Okay, because I use some other counter example, some other concept to solve our example. Okay, so this one is a complete example, solution for complete example. Okay, so my answers are different. When I'm explaining my question, my answers are different. Don't get confused. You may solve any example multiple times. Plenty of the ways are there to solve one mathematical question. Okay, so it is completely up to you which you felt suitable or which your mind accept. Okay, follow that answer. So I hope you all have understood my today's solution. It is completely based on the eigenvalues and a nilpotent matrix. I hope you all have understood my complete solution. So even after if you have doubt difficulty, let me know in the comment section. I'll come up with some other videos. So thank you everyone. Thank you for my today's lecture.